Welcome to this channel. In this particular tutorial, we will design and simulate the NOR gate, and this NOR gate is converted into a NOR symbol, and from this particular NOR symbol we will simulate a half adder circuit. So the NOR gate is designed using the minimum size MOSFET. Before going into this tutorial, I request you to like, share and subscribe to my channel below for more such videos. Now click on New Schematic and click on the Component section. Now in this particular design we require a 2 PMOS transistor and 2 NMOS transistor. So select the NMOS transistor with substrate and place this particular NMOS transistor as shown in this particular tutorial. Now click Escape. Again click on Component and select the PMOS transistor with explicit substrate and place this particular PMOS transistor as shown in this particular tutorial. Now click Escape. Now let us zoom out. Now we have to define an appropriate model for this particular NMOS and PMOS. Also, let us define the voltage source before going further. So place the voltage source V1 and V2 and V3 as shown in this particular tutorial. Now right click on V1 and change the value to VDD. Right click on voltage source V2, define this as VA, where we consider this as A input and the next one as VB, which is B input. Now click on ground and place this particular ground connection on all voltage source. Now click on label net and place the label net VB across the voltage source VB. Next, we have to place the label net VDD across the voltage source VDD, and then we have to place the label net VA across the voltage source VA as shown in this particular tutorial. Right click on voltage source VDD and make it as 1 volt. Right click on voltage source VA and select the pulse. Define the initial value as 0, V on as 1, T delay as 6 nano, T rise as 0, T fall as 0, T on as 3 nanosecond and T period as 10 nano. Right click on voltage source VB and select the pulse. Define the V initial as 0, V on as 1, T delay as 6 nano, T rise as 0, T fall as 0, T on as 3 nano and T period as 10 nano and click OK. Now next, once the all voltage source has been defined, now click on wire and extend the wire across the PMOS. Click on wire, connect the drain of PMOS to the source of M3 transistor and connect the drain of PMOS to the drain of NMOS. Next, place the ground connection as shown in this particular tutorial. Connect the source of NMOS to the ground and the source of another NMOS to the ground. Now click on wire and extend this wire to the PMOS transistor, which is to the gate of PMOS transistor, and extend the second wire to the transistor number 3 of the PMOS, which is the gate of PMOS. Extend this particular wire to the gate of NMOS transistor, and from transistor number 4 connect the gate of NMOS, which is the transistor number 2. Now connect the drain of NMOS 1 to the drain of PMOS and NMOS and extend this, which would be the output for the NOR gate. Now place the label net as AB and place the label net as VA, and we have to place the label net VB as shown in this particular tutorial. Now click on label net and define this label net as VDD and place this label net across the extended terminal and on the substrate of both the PMOS transistor, and place the ground on both the substrate of NMOS transistor. Now right click on PMOS and we have to define the appropriate model. So define this as P underscore 50 nano and define the length as 50 nano and width as 1 micro. Right click on the second PMOS transistor, define the model name as P underscore 50 nano, define the length as 50 nano and define the width as 1 micro. Now you can see that in this particular model file, which is n underscore 50 nano, so the same model has to be defined in our schematic window. So n underscore 50 nano, define the length as 50 nano, width as 500 nano and click OK. Right click on the transistor number 1 and define the model name as 50 and n underscore 50 nano and define the length as 50 nano and width as 500 nano and click OK. Now this particular schematic must be saved in a folder Now click on edit and click on spice derivative, and we have to include this following statement, that is dot include bsim4 underscore model dot text. This particular text file is very important because this particular schematic would call the BSIM4 model in order to perform the transient analysis or the AC analysis. Next, click on the spice analysis and define the stop time as 100 pico and 30 nano and click OK and place this particular syntax on the schematic window. Now we will place a external load capacitance and place the ground connection for this particular capacitance. Click on wire and connect this to the output of the capacitance. Define the load capacitance as 50 femto and save this. Now run this particular simulation and place the cursor on the input VA and click on add plot plane and place the cursor on input VB. Now click on add plot plane and place the cursor on the output of the NOR gate. Now you can see that for 0 and 0, when A is 0 and B input is 0, the output is high, and when the A is high and when B input is high, the output is low. Now, since we have done with this particular simulation, now we will use this particular NOR gate as a symbol. This particular symbol can be used for many gate operations where we would be using it in order to design for the half adder circuit. So remove all the voltage source as shown in this particular tutorial, and also remove all the label nets. Now click on label net and define the label net as VA and define this as port type as input and place this across the wire. Now again click on label net and define the label net as VB. We have to select the port type, so select the port type as input and place this across the wire. Now click on label net and define the label net as AB and define this port type as output and place this on the schematic window. Now save this and go to hierarchy and click on create a new symbol. Now we have to create a NOR symbol. Now click on draw and click on arc and follow the procedure of how to create a symbol from this particular tutorial. Follow this particular step-by-step procedure of creating a NOR symbol. Now, once we have drawn our desired NOR gate symbol as shown in this particular tutorial, we have to place the pin ports. So click on add pin port, define the label as VA and place this add pin port on the schematic as shown in this particular tutorial. Next, we have to place the second add pin port, that is VB. So go to edit click on add pin port and define the label as VB and click on bottom, click OK and place this on the schematic window. What we will do is that we will place the label net as VB and click as top and place this on the schematic window. Next, we have to define the output pin, that is AB pin, as per our NOR gate schematic which we did previously. Now click on line and connect the add pin port VA to the NOR gate symbol. Similarly, click on draw, click on line and connect the VB pin to the symbol of NOR gate and click escape. Now click on edit, click on add pin port, define the label as AB and click on left and click on OK and place this particular add port pin on the schematic window. Now click on draw, click on line and connect this pin port AB to the symbol of NOR gate. Now click on text and place the NOR text on the symbol. Now we have completed our NOR gate symbol, so click on file, click on save as, click on documents and click on library, click on symbol. I have created a folder called as my symbol. Now click on my symbol and this particular folder is specifically for the customized symbol what I have done. So you can save this particular NOR gate symbol in this particular folder. So now click on new schematic and click on component and we will call this particular NOR gate symbol in order to design our half adder circuit. So place this particular NOR gate symbol as shown in this particular tutorial. Now we have to place the NOR gate. So we have to place around 5 NOR gate for this half adder circuit. So place the NOR gate as shown in this particular tutorial. Now we have to place the voltage source for this particular simulation. So click on component and select the voltage source. So this particular voltage source will be the input A and the input B, and we would also take the sum and the carry out. So we have to place a 2 voltage source for this particular design. Click on ground, place the ground connection across the voltage source V1 and voltage source V2. Now right click on the voltage source V1, click on advanced and click on pulse. Define the initial as 0, V on as 1, T delay as 6 nano, T rise as 0, T fall as 0, T on as 3 nano and T period as 10 nano and click OK. Similarly, right click on the voltage source V2, define the initial as 0, V on as 1, T delay as 6 nano and T rise as 0, T fall as 0, T on as 3 nano and T period as 10 nano and place this on the schematic window. Now change the name of the source as VA and VB and click OK. Now click on wire, extend the wire VA and also extend the wire across the voltage source VB. Now click on label net, place the label net VA on the extended wire across the voltage source VA and place the label net VB across the extended wire for the voltage source VB. Now we have to make the appropriate connections in order to design our half adder circuit. So click on wire and make the following connections as shown in this particular tutorial. Now we have to short the pin VA and VB of the first NOR gate, and also we have to short the input VA and VB of the third NOR gate. Now click on wire, extend the wire across the VA of the second NOR gate. Click on wire, extend the wire across the input pin VB of second NOR gate. Now extend the wire from the second NOR gate to the NOR gate 1 and the NOR gate 3, and the output of NOR gate 1 is connected to the input VA of NOR gate number 5, and the output of NOR gate 3 is connected to the input VB of NOR gate 4. Now click on move and move this particular NOR gate in order to make our connections easy. So move this across the NOR gate 4. Now click on wire and connect the output of NOR gate 4 to the input VA of NOR gate 5, and the output of NOR gate 2 is connected to the input VB of NOR gate 5. Now the connections are completed. Extend the wire across the output of NOR gate 4 and also extend the wire across the output of NOR gate 5. Place the label net as carry and also place the label net as sum as shown in this particular tutorial. Now place the label net VA and also place the label net VB as shown in this particular tutorial. Now we have to include the BSIM model. So click on spice analysis and define the stop time as 100 pico and 30 nano and place this on the schematic window, and also save this particular file and place this particular file in the folder where we have the NOR gate schematic. Now we have to include this particular BSIM model file. So right click and copy, go back to half adder schematic, click on edit, click on spice derivative and paste this. So this particular schematic must be saved where the BSIM 4 model is present. Now run this particular simulation and place the cursor on the input. Click on add plot plane and place the cursor on the second input. Again, click on add plot plane. Now place the cursor across the carry so you can see the output. Now let us change this pulse. Let us define the T on as 2 nano and the T period will remain 10 nano and click OK. Save this, run this particular simulation. Now place the cursor on the input VA, go to add plot plane and place the cursor on VB. Again, click on add plot plane, click on the carry and again click on add plot plane and click on the sum. Now you can see the output of the half adder. Now we know the truth table for the half adder. You can see that for the input, when VA and VB is 0, the sum and the carry is 0, and when the input, that is VA and VB, is high, the sum is 0 and the carry is 1, and when the input VA is 0 and the input VB is 1, then the sum is 1 and the carry is 0. Thank you for watching this tutorial. I hope this has helped your learning purpose. I request you to like, share and subscribe my channel below.